Magnetism. Magnets. You know, magnets stick to some things, like laboratory doors. Pretty nice decorations, huh?
Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter. T minus 7 seconds.
Bill Nye the Science Guy.
Magnetism is the force exerted by magnets when they attract or repel each other.
Magnets have two poles, north and south. These poles are attracted together, and the strength of the attraction between the magnets depends on the magnetic force's strength. Magnets attract iron and other metals and materials. One part of a magnet will always point north when it's allowed to swing freely.
Magnetism is caused by the electrons, also known as electricity. When electrons flow through a wire, it creates a small magnetic field around the wire. According to Ampere's law, when this wire is coiled, the magnetic field becomes amplified.
But first, a word from our sponsor.
Very tall metal towers, such as the Eiffel Tower in Paris and the Space Needle in Seattle.
This demonstration is going to show magnetism through making your own compass. What you'll need is a sewing needle, a piece of cork, and a glass filled with water. First, you rub the needle on either a magnet or your jeans, allowing it to have a static charge and making it magnetized. Then you place the cork on top of the water and then place the needle on top of the cork, and the back of the needle should point north. As you can see, it does. And if you introduce another magnetic field towards the needle, the tip of the needle will point towards that.
Magnetism. An electromagnet's any soft core metal which has the current flowing through it. An example of this would be a wire. When a current flows through a wire, it creates a small magnetic field around it, and this magnetic field is pretty weak. When we coil that wire, the magnetic field becomes larger, and we put a metal rod through the center of the coil. It amplifies the current. And also when we increase the voltage of the power source, it also increases the magnetic field. Now, in order to make one, all you need is a nail or a metal screw and a piece of wire, and you're going to wrap that around very tightly, but I'm not doing that because for time reasons. And then you're going to attach a battery in between it. Now, I have one that I already made, and this one, and these are some stuff to pick up with it. Now, when the circuit's not complete, there isn't any current flowing through the coils, making a magnetic field, so it's not going to pick up any of these metal objects. But when I complete the circuit and go back to it, now there's a magnetic field, and when I let go, it turns it off. It disconnects it and drops the it's not that strong. Anyway, and the stronger your battery, and increase the voltage, the higher the magnetic field will be, and then you'd have a stronger magnet.
But first, a word from our alternate sponsor.
You know what we call moving electrons?
No.
Call it electricity.
In this demonstration, I will be showing a physical representation of magnetic fields. A magnetic field is an invisible field that exerts a magnetic force on substances that are sensitive to magnetism. What I will be doing is I'll put a paper over this magnet and then pour iron filings onto it. Since iron filings are sensitive to magnetism, the magnetic fields will be able to act on them, which causing them to appear as though there's lines in between them, which are the magnetic fields. Now, what you can see here is you can see the formation of the magnetic fields. It's almost as there's clean lines between all of the iron filings. This is due to the fields, since it's acting with that force, parting them, and making them, some of them even stand up a little bit. And this is because the forces go out all different ways, not just in the vertical and horizontal. It is hard to see from a vertical view, but it's clear that there is something parting these filings, even though I simply just poured them on. This is showing that the magnet produces these fields, and it has enough force to move these filings to certain points. Also, you can start to see that it almost curves inward, showing that it has a more circular field, like most fields, and even though it is a square magnet.
Action.
Hold on.
No, absolutely not.
And then
Magnetism. Knowledge.
Can I just fart?
Yeah.
I swear to God, Nate.
Ready, Europa.